Welcome back, my students. I'm here with another lesson in the same topic. Remember, we're discussing about the chord properties of the circle. Like, follow the previous videos and be able to see where we are. Like, so far, without wasting any time, we are discussing something about the chords which are equal. Remember what we did in the previous video? You can follow the link down here. That we really even proved that say chords which are equidistant from the center of the circle are always equal. Say for example, I've got this chord here and this chord, and if this chord AB is equal to chord XN, and this is the center of the circle, and it's found that say this chord AB is maybe, look at this one, or N, or M from the center, and this called XN is O D from the center. Right, as much as this called AB is equal to XN, what we saw and proved that distance OM, which must then be perpendicular to AB, must be equal to distance OD, which is perpendicular again to what? XN. And the converse is true. That say, if we have got chords which are equidistant from the center of the circle, they must be equal. Meaning to say that OM, if OM is equal to OD, then AB must be equal to what? XN. So now, let us look at two examples of which can at least be applied in what we have just discussed here. Right, so on my chart, I've got two examples where we are going to use the knowledge about what we have just discussed in the properties that talks about the chords which are equidistant from the center. Like the first example goes like this. Two equal and parallel chords of the same circle have a length of 12 centimeters. How long are they from the center, given that the center has a radius of 9 centimeters? Right. So as I always say, the first thing you need to do, you need to interpret the problem from the diagram, so that you can really exactly see the variables within it and analyze the part that is supposed to be found. Right. So here, if I'm to draw a diagram representing this information here, it means I'll have a circle as stipulated in the question itself, which goes something like this. Height. They say we have got two equal chords which are parallel. So I can have one chord, which is this one, another one, this one. Right. These chords are parallel. These are the identities, the arrows. Right. And we're told that say these chords are equal. I can describe them by the letter A, B, simply signifying chord AB. And this other chord, let's just describe it by Y, N. So these two chords are equal. Let us understand it, and they're parallel. Right. So we obviously expect this chord to be of a certain distance from the center. Like say the chord AB is OH from the center, and this other chord YN is OD from the center, and they must be perpendicular because these are distances from the center. It must be perpendicular distances. So AH or D are distances. So here we are also told that say the circles have got a radius of 12, not 12. The radius of the circle is 9. So which means in this case, if you can draw one of the line that represents the radius, I can choose to draw LN to present the radius. And this line is 9. Right. We are told that the chords which are parallel, they are 12 centimeters. It means from here it's 12, and from here again up to that is 12. So when the question now is asking us to find how long are they from the center, what the question is trying to ask us is just a matter of finding the distance both chords are from the center, each one of them. How long is it from the center of the circle? It's just like how long is chord AB from the center which is just like what is the value of OH. And again, at the same time, it's also asking us to find how long is chord YN from the center, simply meaning that what is the distance of OD. So since now these chords are equal, by the formula, by the theorem, which I've already discussed, that's the property I've just discussed, that say equal chords are distant from the center of the circle. So it's just a matter of just working out one distance there. You just have to find the length of one distance from the center. Like say if I wake up the distance OD, that is the distance of what? A chord from the center. The same will apply to this one. So that wasting time working out OD and also OH, let's just find one value, like say OD here. And that is the response to the question. It means we have found the value of OD, that is the distance of YN from the center, and this is the same distance from the center of AB, because the chords are equal. So in short, in brief, let's just find the value of OD, and that's the response to this one. Right. Now, if we get into this triangle, which is described as ODN, you'll be able to see that triangle, that's the ODN, is just right angled by its nature. Because this line here is a distance from the center, it must be what? Perpendicular. So as such, with the remaining two sides, that is ON and DN, they form a triangle which is right angled. So what we do here, we just have to find the distance from D to N, mark that we're given ON, right? Then we'll use Pythagoras theorem. Right, I already told you that this type of problem, most of the times, they work better when you use Pythagoras theorem, because we are always dealing with the right angle triangle. So once you find the value of this one, then we'll be in the position to find the value of what? OD as such. Right. Now, to find the value of DN in this triangle, what we do, we can really apply the first property, which says that a chord C, which is okay, let's take it to say a line that is perpendicular to the chord coming from the center. Remember, we discussed that that line bisects the chord. So as it is here, we know that from here up that is 12 centimeters. So what we expect is that, let's say this line is coming from the center to the chord and is perpendicular to the chord. Our expectation is that this line is bisecting the chord. They say dividing the chord into equal parts. Such that if from here up that is 12, we expect from here up to that to be 6, and from here up to that also to be what? 6. Right, so that one we can consider it as one of the steps that will lead us into the solution to this problem here. So here I would like to say in this triangle, we have our line DN is equal to half line what? YN. YN. The reason is what I've said. You can write it here to say OD by 6YN. Right. This then will be substituted for YN with 12. That, and then you have got our DN as 6. So which means here 6. So to find the OD in this triangle, we use Pythagoras theorem. So here you write by Pythagoras theorem, what do we have? This is the hypotenuse side. So we know if we square that hypotenuse side, in this case, talk of 9 squared, that one is just equal to the sum of the squares of the remaining two sides. So here also write that say one of the side is 6, which has to be squared, plus what? OD squared. That is of our interest, because we're interested to find the distance from the center to the what? To the chord. Now, if we can simplify this one out, we have this one as 81, and this gives us what? 36, and here we have got plus OD squared. By the simple method which you already know, like terms together, it means you have 36 to the left hand side, where it be 81, such like negative 36 is equal to OD squared. Right. Going further with that, we'll be able to see that the value of OD squared, I'll write here because of space, right? I'll have my OD, 81 minus 36, that gives us what? 45. So this side we have got 35, which is equal to OD squared. Then to find the value of OD, we need to take the square root on both sides. Square root of the OD squared, which is OD, and then square root of the 45, which comes in something like this one here, square root of 45, like that. Look at that. So if we want to find the value of OD, our OD comes in as 6.521 decimal place. Right. So it means the OD is 6.5, 6.7. This is what it is if we're going to present that value here in the diagram. It means from here to that is 6.7, and here from that must also be 6.7. The reason is just the two chords are equal by just the previous property which talks about the equal chords are distant from the center of the circle. We are applying that. So that's it about this. So here it means that say the chords are 6.7 centimeters from the center. Right. So that's it about it. Now let us also go to example number 2. Like this doesn't necessarily need the property which I've discussed. Sometimes you can add the knowledge of which plus the other properties which you have done. So it's more like a general question which we'll see what it demands and what type of knowledge we need to portray within it. But all in all, you can be able to see that the problems here, they're more just like alike. They're just talking of the same things, chord, center, talk of the distance from the center and the radii, and moreover, these are the variables are working, but the design just means the same. Pythagoras. Right. So now let's discuss the second example. Right. So remember, every time you are handling problems which are in words, diagram must be drawn. Right. So that you should be able to analyze the question very well. Right. Now let's go to the second question where we told that say we have got FH is a chord of the length 16 centimeters and is 10 centimeters from the center. We are asked to work out the length of a chord which is 12 centimeters from the center. And we are asked again to leave our answer in simplified side form. So which means the topic about the irrational numbers comes in here, about the sides. Right. That's what I like about mathematics. At least the knowledge of one comes into the other one and apply that manner. So here, let us now draw the circle first and see the information in the form of a diagram. Right. So here is obviously, first of all, a diagram which is described by a circle like this one. Then now what I'll do, I'll draw a chord defined as FH, which is 16. So here is my chord. I'll draw it like this one, and I indicate it FH. This is 16 centimeters. And obviously, here's my center O. Then now, what is it? They say this chord is 10 centimeters from the center. So what I have here, it means the line I have to draw here from the center to the chord here. That must be a perpendicular line, which is defined in this case as O. Let us define it as O, maybe D. So from here to that, we know it is 16 centimeters. So OD is 10 centimeters here. Look at that. Right. Then now, what we are asked to do here is simply to work out the length of a chord which is 12 centimeters from the center. So which means in my diagram, I need to draw another chord. So this chord at least should be a little bit shorter, right? If we are to relate with the first one, which is 16. So here I will describe this chord by letters like Q, Z, no problem. So this chord QZ, we can take that is 12 centimeters from the center. It means the distance from the chord to the center, I will represent it by this line here. And this line should also be perpendicular to that chord like that, because it is a distance, which is this must be a perpendicular distance as such. So it means O, I will have this point here fixed as T. So we consider OT as the distance of the chord QZ from the center. And we are given 12 centimeters. So just like the first chord FH is 10 centimeters from the center, and the other chord QZ is 12 centimeters from the center. So what we are asked here is simply to find the length of this chord, which is in this case QZ. We need just have to find the value of QZ. Right. So first I'm going to explain how we do that, so that I have to just move faster in this case and light it up. Right. So if we are to find the value of QZ, remember by the application of the first property, that's a line from the center to the line from the center, as far as that line is perpendicular to the chord. Remember that line bisects the chords. So here, what we have, just like here, we've got OT perpendicular to QZ. What we want is to find QZ. So what we do, just like now, if we know just one of these distances, let's say for example, if I know the value of TZ or TQ, I expect that any one of those sides should be half of the entire what? Length. Right. Why? OT is perpendicular to what? QZ. And we expect this line to divide QZ into two equal parts. So here is just like as good as finding the one of these distances, either ZT or QT. And you find one of them, we'll just multiply by 2. Right. Because QZ is divided or split into two equal parts by the line OT. Right. So in my case, I'll just target to find the value of TZ. What is TZ? You can even choose to find the value of TQ as such. Then just multiply by 2. Right. That's what we can do here. So now, here we go. How do we find all the side TZ? Let's choose to find TZ together. We go by that. Right. So now to find the TZ, what we need to do is at least construct a triangle that is right angled, so that we can use Pythagoras theorem. That is the first knowledge we need to consider. If we fail that, maybe we can go to something else. Right. So now what we do here, let us join Z or like this. Right. So that we should have a right angle triangle OTZ. So to find the TZ, it means we should know the value of OZ in this case. Right. But OZ is not given. So what should we do? We need first of all to find the value of OZ. Right. So to find OZ, yes, not easy. But now, if we can go to the other side of the diagram, which now considering the issues about FH, which is 10 centimeters from the center, we can be able again here to construct a triangle which is right angled, where we may have O to H like this one. And this line, we obviously know that this one is the radius. The same, this one is the radius. So if you talk of line OH, this OH must be the same as OZ. So what I do is this, just like if I need to find the value of OZ, I need just have to find the value of OH. So to find the value of OH here is easier, because I've got enough information here. I know that from here up to that is 10, and from here up to that, usually we know that this one is divided into two equal parts, because this line divides FH, is joining at the midpoint here of FH, which is D. So if from here up to that is A is 16, we expect that from here up to that should be, not from here up to that, but now from here up to that should be what? 8 centimeters. So here in triangle ODH, we expect to have this one as 10 and this one as 8. So 10 and 8 will help us to find the value of the radius, which is OH. And the value of OH will be the same as that one, which is what? OZ. Then here we're going to treat issues using the Pythagoras theorem, and we are done. This one will be found and multiplied by 2. Right, so now let me write what I've just said here. So I'll begin by saying, in triangle that is ODH, we have side DH first. DH is equal to what? Half the 16. Why you write here? To say that OD is perpendicular to what? FH. That is the reason. And here you get 8. So you have got 8. Therefore, what? We need to find OH, which is the radius. That is the same like this one here, that side here. So what do we have here to find OH? We'll have it like, let me represent OH by a variable R. Then this one will also be R. So it'd be like R squared should be equal to 10 squared plus 80 squared by Pythagoras theorem. Right. So what do we have here? R squared is equal to 100 plus 64, which gives us 164. Right, so that is the value of R squared. Now, if we can look at that one, if we need to find the value of R, in this case, we need to take the square root of 164, like this. So it means, as much as our interest is not to find the value of R, there's no need for you to simplify that one into the decimal fraction. You can just leave as it is. Unless this is a perfect square, you can find the square root of 164. It's okay. But as far as this one is going to take to decimal number, and yet that is not the variable that you have been asked this question, please leave it like that first of all. Right, because you are going to change that number. The moment you are going to construct it, you are going to approximate it to a certain number of decimal places. So it means if this is a square root of 164, then this one should also be 164. So here, I'll go back now in triangle, that's a O T Z, right? So this is square root of 164. This one should also be square root of 164. I'll also use Pythagoras theorem. I will need to find the value of TZ. Right. So here it works the same. My TZ will be defined by this one as my hypotenuse side. I'll write that one as the OZ squared, which is the root of 164 squared is equal to what? This side squared, that is 12 squared plus TZ squared. So my target is just to find the value of TZ, this TZ here. Right, so that I have to multiply it by 2 to find the entire length, which is QZ. Right, so now what are we going to have now? So what we have here, just like when I take the square of the square root of 164, you see now it will be easy, because this one is not expressed in the decimal number. The answer comes as 164. The other side have got 144 plus TZ squared. This will come here, like terms together, you have got 164 minus 144, which is equal to TZ squared. So 164 minus 144, the answer is 20. Right, which is equal to TZ squared. Look at the way we solve the problem here. So now from here, TZ is equal to TZ squared is equal to 20. How do you find the value of TZ? So we go again by the same processes of the Pythagoras theorem. We are going to take the square root on both sides. So here it means our TZ should be equal to the square root of 20. That is the value of TZ. Right. So now this being the square root of 20, then what we want is the value of QZ. From what I said, if we find the TZ, this is just like half of QZ. So if I want to find the QZ, which is the length of this chord, which is 12 centimeters from the center, I need just have to multiply this one by 2. So here I'll have, therefore, my QZ should be equal to 2 times the square root of what? Of the 20. I'm failing to take the square root of 20 because the instructions, they say, leave your answer in simplified side form. So which means QZ is 2 square root of 20. So here, if I'm to simplify, I know for sure that root of 20 is a side. So by what we discussed in the previous videos, when we're working on the irrational numbers, you'll be able to see that when you're simplifying the sides, just find 2 factors of the number inside the root. One can be a rational number, but another one should be a perfect number. So if you look at 20, we have got a 4 multiplied by 5. 5 will be like a rational factor, while a 4 is a perfect number. So I can take the square root of a 4 as a 2. That 2 will be multiplied by a 2 outside here. So here it means I'll have got a 4. But the square root of 5 is not even, like, so it means 5 will be left in the start form like this one. Root over a 5 like that. So which means the length of a chord here, the chord you like to say is 4 root of 5 centimeters long. Right, so that's the way we can handle the last question here. Right, so please students, can you go and revise these examples here, plus all examples which we have just done. And this marks as the end of the first category of the properties of a chord. Right, so please just revise. They will not give an exercise, right? I know you have got a lot to do. The other time, I'll just give you a lot of exercises that you can write. But just like go through this one, plus the other examples and exercises we have already done. Right, so in the last meeting, in order to finalize the topic, we are there going to discuss the last section, that is about the chords which are intersecting inside and outside the circle. So we need to know what is it about them. Right, so let's end here this time. Thank you very much for being together. Remember to go through the videos which we have just discussed in the past. Thank you very much.